So this one flew under the radar for a lot of people. Kotlin 1.9 included a new experimental HexFormat class that can be used to convert hexadecimal strings into numbers or byte arrays, and the other way around, so both formatting and parsing. And I think this one's got a lot of good utility. I know I've worked on projects in the past where I needed to slap together some kind of a hex parser or formatter, and it would have been great to have this option in the standard library, especially for multi-platform projects. You've probably seen a URL with percent encoding like this, and this %20 represents a space character in ASCII. The number here is in hexadecimal, so even though it looks like it's the number 20, it's actually decimal number 32. Now, even before Kotlin 1.9, we've had the ability to write hexadecimal literals in our Kotlin source code, and we do that by starting the number with 0x. So I'll create a variable, and we'll make it a byte, and we'll set it to 0x20. And when we print this out, we're going to see 32 because the number is printed in decimal. But what if we want to go the other way around? What if we want to start with the number 32 and we want to see it rendered as a hexadecimal string 20? This is where Kotlin's HexFormat tooling can help. Now, before we do anything else, HexFormat is an experimental API in the standard library, so we'll need to opt into it. To do that, we just add this annotation, opt in, and we say experimental standard library API. Okay, next I'll create a variable called hex, and we'll say byte, and then we'll call an extension function named toHexString. And then finally, we'll just print this out. Now, when we run this, we are back to 20. Now, this probably goes without saying, but we can assign this value in decimal instead of hex, and all of this works exactly the same. Now, instead of just 20, we might want some character at the beginning of that string. So for example, with the URL encoding, we had the % sign at the beginning. We could, of course, just use Kotlin's string templating to do that for us here, but that's going to be tedious if we had multiple numbers to convert. So instead, I'll put this back and let's create a HexFormat instance. HexFormat gives us a chance to specify how we want Kotlin to format those hexadecimal strings. So to start with, we'll just create a variable called format, and we'll assign to it HexFormat with braces like this. Now this looks like a constructor. It's technically an inline factory function, but serves the same purpose. Now inside this block is where we can specify how we want the formatter to work. Since Kotlin is statically typed, we can just open the code completion menu here, see some of the properties and functions that are available to us. For now, I'm just going to type number.prefix and give it the % sign. And now that we've got a formatter, we just need to pass it to the toHexString function here. And when we run this again, we see that we get %20. Now I'm using a byte type here, but we can use any integer-based number type in Kotlin. So that would be bytes, shorts, ints, and longs. But we can't use it with floats or doubles. Now you might be surprised to discover that the type of the number affects the hex string that is output. So if we change this from byte to short, then the hex string has these two leading zeros. The number of hex digits in the output is going to be based on the width of the number type that you're calling this on. A byte is 8 bits, and since each hexadecimal character can represent 4 bits, that means we can represent a byte with 2 hexadecimal characters. But shorts are 16 bits long, and that's why they need 4 characters to represent them in their entirety. And similarly, ints are 32 bits, and so you need 8. And long is 64 bits long, and so you need 16 hex characters to represent them. There might be some cases where you're using a larger number type, but you don't want those leading zeros on there. And so when that's the case, you can turn them off in the formatter. To do that, we'll just type number dot, and here we've got this remove leading zeros property, which we can set to true. And now we're using a long, but it renders the same way as a byte did. And I can see this being helpful for cases where you're going to use a 32-bit integer to represent a 24-bit RGB web color, for example. And now that we've got this format defined, we can use it not just for formatting hex strings, but also for parsing them. So let's turn things around. We will start with a hex string and get a number out of it. So to parse a hex string, we're going to use one of the extension functions that start with the word hex. In our case, we want to convert it to a byte, so I'll say hex to byte, and don't forget to pass it the format. When we run this, we can see that we're back to decimal 32. And keep in mind that if you've got extra characters, on the beginning of that hex string, you'll need to make sure that they're specified in the format for it to run properly. Otherwise, you'll get a number format exception. Now, we've been using HexFormat to convert very small values, but there are some cases where you've got a very large hex string. For example, UUIDs are 32 hex characters long. Same thing with IPv6 addresses, 32 hex characters long, which means that they're both 128 bits long. And the largest number type in Kotlin is a long, which is 64 bits. So if we're going to represent a UUID or an IPv6 address in like a number type in Kotlin, we would have to stick two long numbers together to accommodate it. In cases like this, instead of using a number type, we can use a byte array to represent that number. So here I've got a byte array that's made up of 16 bytes, each of which is just cleared out to 0. And hey, by the way, don't sweat it if you're having a little trouble keeping up with the math on this stuff. I'm sure if you sat down and wrote it out, you'd keep up with it just fine. The main idea here is just that a hex character can represent 4 bits. We've got IPv6 addresses that are 32 characters long, so that's 128 bits. 128 bits divided by 8 bits per byte gives us 16 bytes that we need in this array. So that's how we ended up with 16 here. So when we run this, we get 32 zeros, just like we thought we would. But this isn't formatted very nicely. Typically, an IPv6 address has a colon between every 4 hex characters. So let's create a hex format for this one. Now, hex format has 2 different types of configurations. One of them we've already used, and it's called number. And so if we look back at our previous code, we can see here we've got number.prefix and number.remove leading zeros. And this number configuration is the one that the hex formatter will use when you're converting between a number type and a hex string. So bytes, shorts, ints, and longs, if you're converting between those and hex strings. The second configuration is called bytes, and that's the one that's used when you're converting between a byte array and hexadecimal strings. So that's what we're going to use here. So here, let's type bytes dot, and code completion shows a few options that we didn't see before. In our case, we want to group these hex characters into sets of 4 hex characters each. So to do that, we're going to use bytes per group, and we're going to set it to 2. And remember, that's 2 hex characters per byte, so that when we specify 2 bytes here, we'll get 4 hex characters in each group. And then bytes.groupSeparator is the string we want to use to separate those groups. So we'll just set that to colon. With this, we get 32 characters with the correct grouping for an IPv6 address. We got one more problem here though, and to demonstrate that, let's make these bytes random. When we run this, we can see the letters A through F are in lowercase, and for IPv6 addresses, typically they're shown in uppercase. So to remedy this, we can just update our hex format. We can say right here, uppercase equals true. And there we go. That now looks like an IPv6 address. Now, one thing that I wanted to be able to do with hex format, but I wasn't able to do, is format a UUID. We saw with the IPv6 addresses how they're grouped into 4 characters each, and that's uniform throughout. But with a UUID, you've got a group of 8, and then a group of 4, group of 4, group of 4, and group of 12. So it's not uniform. And the best I've been able to come up with is just to convert it to hex with the default hex format, and then use a regular expression on it. Alternatively, you could group it into 4s and then do some acrobatics to remove the unnecessary hyphens, like this, which I'm not particularly proud of. Anyway, hex format is an experimental feature, like I said before, and I'm sure the Kotlin team would love to hear your feedback about it. So I'm going to leave a link in the description where you can do that. All right, I'm out. See you next time.
You've read the chapters online, and now I'm proud to present the Lean Puff edition of Kotlin, an illustrated guide. Take the book offline with you, mark it up in your favorite PDF software, and get early access to new chapters as they're written. You can pick up your copy today. Just go to book.typealias.com.